Hello everybody, I hope you guys are doing well. This video is going to go over topic 2, lesson 5, example 5, and this one they just throw you right into the lion's den here. They're going to give you an equation and we have to put it in vertex form, and what they did here is they gave us a leading coefficient that's not equal to 1. So my a in my quadratic is not equal to 1. So they want us to write the equation of y equals negative 2x squared plus 10x plus 1 in a vertex form and graph it. What is the maximum or minimum value of each of the equation? All right, ready? Ready, let's tackle this. Here we go. Let me go up to the problem. Okay, the first thing I need to realize is what is vertex form? And vertex form is going to be y equals a x minus h squared. So here's our perfect square that we are going to use completing the square for, plus k. All right, looking at this, I cannot factor this easily, which is probably why they want us to do it in the perfect square. If I do negative 2 times 1, that's negative 2. And there is no way I could make anything that's negative 2 into a 10 by adding it. So I'm going to jump straight into the problem. I'm going to have y equals negative 2x squared plus 10x plus 1. And I'm going to do this thing that we hardly ever do. We hardly ever show. I'm going to use the y side as kind of like a placeholder for my negative 1. All right, the next thing I'm going to do, if you notice in the vertex form, we have this a and then x minus h squared. And my x here does not have a coefficient. The coefficient is now on the outside. So to do that, I'm going to pull out the greatest common factor of my leading coefficient. It might make this number a fraction or a decimal, but we get this into the format that it needs to be in. So this is y minus 1 equals negative 2. I'm pulling that out. So then I'm going to do negative 2, divide each term, and I get x squared minus 5x. Now I'm going to do this in pieces because it's a multi-step problem. So I'm going to focus on the parentheses, and I'm going to make these parentheses a perfect square. So I'm going to do y minus 1 equals negative 2. And remember, I told you that c component is going to be b divided by 2 squared. And in our case, we're looking at negative 5 divided by 2 squared, which is going to be this nice number, 25 divided by 4, not 2. So now I'm looking at x squared minus 5x plus 25 divided by 4. Now I added the 25 divided by 4 here, but remember that this 25 divided by 4 is also being multiplied to this negative 2. So what I do to one side, I must do to the other side. So I'm going to do 2 times 25 divided by 4, and I'm going to add it, or in this case, subtract it from the left side. So y minus 1 minus 2 times 25 divided by 4, because this is the value that we've added to the right side. So now we're going to do it to the left, equals negative 2 x squared minus 5x plus 25 divided by 4. Is that 2 and that cancels out, so we have 25 over 2. I'm going to make this 2 over 2 so that I could easily combine them. So this is negative 27 over 2, I believe. 25, 26, 27, yeah. Equals. And now I'm going to do this as the perfect square. So remember, the perfect square formula is going to be x plus b over 2 squared. So now in our case, So it can be x minus 5 over 2, because this is negative, squared. All right. Vertex form. I'm going to add the 27 over 2 back to the other side. And I get y equals negative 2 x minus 5 halves squared plus 27 over 2. All right, so my vertex in this case is going to be 5 halves, because remember we changed the sign here, comma 27 over 2. Now, as much as I love fractions, and I actually do, I think I'm one of the only people out there in the world that like fractions, I do not like them to graph. And since we have to graph this, I am going to turn this into decimals, because on a number line, like a graph, I like to know the decimal points for it. 13.5. Okay. Now the second thing I need to know is my zeros. So it's basically what happens when y is equal to 0. So I'm going to make y equal to 0, or x-intercept. Because we do need to graph this, so I need to know where this crosses the x-axis. And what I'm going to do is I'm going to say 0 equals negative 2 x minus 5 halves squared plus 27 halves. Subtract the 27 from both sides, minus 27 divided by 2 equals negative 2 x minus 5 halves squared. So we're kind of back to where we were just a little bit ago, except now instead of having y, we have nothing. Divide out by 2. So we have 27 over negative 27 over 4. Oh no, negative 2. So this becomes a positive. That's a horrible looking positive. Let me change it. It's more like a pi than a positive. Right. Okay, we're going to take the square root of both sides. Now this is a plus or minus because we did take the square root. Ooh, that's not a nice number. That's like the square root over 27 over 2 equals plus or minus equals x minus 5 halves. Add 5 halves to both sides. And guys, all I'm just doing here is getting x by itself. There is no actual math magic in this. It's just doing all the steps to get x by itself. And we are looking at 5 halves plus the square root of 27 divided by, I'm using my calculator for this. I'm not doing this mentally in my math. Not mentally in my head. I'm not doing mental math, that's what I was trying to say. So the first one is 5.098. Always got 3 decimal places. And then the next one is going to be negative 0.098. All right, so if I'm looking at this graphically, that is a parabola that I'm going to use later. That is not a straight line either. Bam, bam. My vertex is here in the first quadrant. This is 5 here, and this is negative 1 basically here. It crosses the y-axis at 1 here. Now let's see if I can get this. I think the dot is kind of far over. No. Good thing about me having the computer and drawing everything is I can move what I need to, where I need to. So this is 1. This is roughly 5. This is roughly 1. And this opens downward. And I know that this opens downward because of the -2. All right. The negative tells me that my arrows go down to the negative. All right, so let's see what the book does. Let's go through the book. So they do exactly that, and then they find the perfect square. They go straight with decimals. And that's okay, but when I want you to be precise, sometimes I do want you to use those fractions, but jumping straight into decimals for this, since we were graphing, is perfectly fine. So they get their points at y equals 13.5 and 2.5. That's what we did. And, oh, I went further. I found our zeros. So they didn't even want you to go all the way to find your zeros. So when you do your homework, and if they do not ask you for the zeros, you don't have to go that far. So I hope that this video at least clears up a little bit misconceptions or anything like that, and helps you understand the subject a little bit more. But if you have any questions, please contact me as soon as possible, and we will see you in the next video.